Love to see you jamming the music.
You know what I read earlier this week, because I'm very interested in mental health and in particular, what are interesting and unique ways that we can support mental health. And it's almost it's so often said between you and I both when we're talking with people and we talk about exercise, like go exercise. And there was recently a study that was released that has been able to one up exercise a little bit, and it's a specific form of exercise. It's dancing. So they
Yeah,
found that
nice.
dancing as a form of intervention for mental health gives better outcome per se than just like your cardio or your weightlifting or whatever it might be. So I now justify my bad dancing wherever it is I go.
Well, and it's good to start them young. Every morning, bring my granddaughter downstairs, get her milk and do things, and I turn on the music and we dance, and she is so darn cute. She bebopping away and moving, and she's got some moves for 18 months old. I love it.
I know we're taught to refine our moves as we get older, and that's sometimes, except for the ballerinas out there, is not a good thing. Well, I am so very excited to be here with you this evening, Dr. Varden, because I think we get to start, or we're at least going to dig into a question that's very applicable to your granddaughter there. We're going to start digging into the question of nature versus nurture, and what are one of the mechanisms that influence that balance between the two? Yeah.
Absolutely. I'm so excited about this. This is actually one of my passions and one of the areas that I studied in grad school for my PhD.
And how delightful, how fortunate we are in that effectively we get to navigate this time with you. And I'll be asking a lot of questions about that, given this is something you've studied so much within. And so I'd ask that Dr. Varden and I are now going to start a little bit of an introduction. We're gonna answer what is epigenetics. We're going to set the stage a little bit, and while we do that, I really do encourage you to answer and to respond to our poll questions because we really want to know who's here with us this evening. What do you guys know? What are you seeking to know? Okay, so our goal. Just so you all are aware of what we're trying to share, is we want to first teach you what is epigenetics, right? How does that express within you? And then knowing that, how can that impact your health? How can you use this idea of epigenetics to support you in living whatever version of health is most meaningful to you and most important to you? Yeah, so
And with the
mm,
bottom line, the understanding that your epigenetics, it is modifiable. You have the power to affect the way your genes are expressed.
yeah, yeah. I think that very powerfully is if you turn this off now and you hear nothing else, be very mindful that while you can't change your base DNA, you can very much on a daily, on a monthly, on a yearly basis change your epigenetic presentation or that which influences the genes that you can't change. So, Dr. Varden, why don't you open us up here with what exactly is epigenetics? Bring us back to the definition, bring us back to what exactly are we talking about here today?
Absolutely. And this is where I'm putting my teacher hat on. So epigenetics, this is the study of changes in genetic expression that do not involve the alteration of the DNA itself. So these changes can be triggered by environmental factors like Dr. Kostroman was talking about. So we're talking lifestyle choices, the foods that you eat, different environmental factors that you are exposed to. All of these influences that turn genes on or off, effectively influencing how the cells read the genes. So if we are looking at the etymology, okay, the history of the word and what the parts of the word means. So the prefix epi in Greek means on top of or in addition to. So reflecting on how epigenetics changes occur on top of the existing DNA sequence. And there are different ways that it does this, that it
Yeah.
affects how the genes are turned on or off, how it's silenced or might otherwise make it active. And these are things like DNA methylation, which you may have heard of that phrase before. Oh, like methylation pathway, and different things. Yeah, that is part of it. But what ends up happening is that it DNA methylation is where a methyl group attaches to the DNA, and this often leads to the suppression or the silencing of that gene expression. So that, you know, quiets the genes.
Mhm.
There's also histone modification. What the heck is a histone? Well, histones are proteins. These proteins are around, the DNA is wrapped around them, kind of like a thimble of thread. And the thread is the DNA. So it's wrapped around those nice and tight. Okay. And modifications in those histones, those proteins, like acetylation or methylation, they can alter how tightly that DNA is wound, which can affect the gene expression. Like the DNA actually has to be loose, unwound
Mm.
from that histone in order to be read. If it's wound up, it's not available to be read. So that's something. And then another way is through non-coding RNA. Remember, uh, RNA being the part of the DNA, like one-sided DNA, these single strand. Okay. And the RNA molecules, what they do is they regulate the gene expression by binding to messenger RNA. And I know a lot of you may have heard of mRNA now, especially over the last, 4 years. But that what happens is it attaches and it prevents it from being translated into a protein. So those are three major ways that gene expression can be modified or can be silenced. So
Okay. Yeah. So if I'm hearing, so we have, and let's jump back to music because that's how we started with our great music and our great dancing. So if I'm hearing you correctly, we all walk around with a sheet of music that kind of says, here are the notes, here are the song, here is how the coding of your body, but it's not so simple as just simply reading off that because we know there's an artistry to music, right? How quickly you play it is going to change how those notes are. And so those things that you've just mentioned, the non-coding RNA, the histone modification, methylation, these are kind of ways that we mark up that music sheet. Is that what I'm hearing?
yeah, well, it actually can go a little bit beyond there because the music sheet,
Yeah.
that is your DNA. That's not going to change. What can change, however, are the players, the orchestra, the
Mm,
instruments themselves. Um, there, and which we'll dive into a little bit more, working on the analogy of music and using an orchestra as our analogy for epigenetics and the way that works. Um, it really is a matter of the players, the conductor being the epigenetics,
mhm.
and the orchestra and the different instruments being the genes. So, but the sheet music itself, that's our DNA, that doesn't change.
Okay. Okay. So if you have a sequence of notes, that's not going to change. But what can change is how it's played and how it's told to be played.
Yes.
Yeah. Okay. All right. Well, why don't before we kind of dig into, you know, how that direction can kind of happen, let's tackle the question of how important is your DNA, that coding that we can't change, compared to some more of the environmental things like epigenetics, the things that sit on top. Like, do we know as scientists, as clinicians, are they one and the same? Are they equal influence? Does one have more importance than the other? Like, is my DNA more important, or is kind of my nurture, what I do about it, this epigenetic layer, is that more important?
Well, I'll tell you that has been a one of those questions that has um, really plagued so many researchers across the board
And you're
for
going to solve it tonight, right?
oh yeah, just like that. For so long. I mean, there are thousands of
Yeah.
papers looking at exactly that, and diving into the weeds of it. But really, there was a seminal paper back in 2015 in Nature Genetics. It was a massive meta study that analyzed more than 50 years of data on almost 18,000 traits measured in over 14.5 million pairs of twins. So we are talking a very robust, huge number of
Yeah.
people. But they determined that heritability, okay, so your genetics accounted for 49% of all traits and environmental influences for 51%.
Ooh, ooh. So that paper was so bold to say it's pretty 50-50, but what you do is a little bit more important.
Yeah. I mean,
Interesting.
look at the studies that have been done on twins. And I mean, there's over 100 years, worth going back where they have studied twins
Yeah.
and, different situations that they were in, or one, became sick or was, had some sort of toxic influence or whatever, and the other
Mm,
one did not. And the differences of
mm.
their growth, progression, aging, everything else, yet they have the identical genetic sequence. So
Interesting. Were those studies like, so when it said, it's approximately 50-50, was that across the board? So all body traits, all personality traits, or was there a difference between different areas as to how much genes influence compared to how much environment and nurture might influence?
they actually, it was an analysis where they did look across the board.
Hmm.
But of course, a lot of this was going back when you're talking about meta studies. You are looking, not all of the studies that they had looked against have all the same type of information that was being tested.
Mm,
It's,
okay.
quite broad. You have to look at, each study, what they were
Yeah.
specifically looking at. So it was basically a compilation from, these different, all of the different studies, the meta studies, when they
Okay.
were looking back. It was the overall picture that they came up with that
Okay.
percentage. But there are, within each particular systems, and this works into the individual studies. If you really start diving into those thousands of studies where they looked at something
Yeah.
specific in twins, that can shift a little. So
Mm.
that near 50-50, is more of that overarching governing, average.
Yeah.
But
Yeah.
still,
Okay.
it's not.
Yeah, because I think, oh, sorry, I think, okay. I didn't catch what you said there.
Oh,
Can you say that
I
again?
was just saying about how strongly impactful the
Mm,
environment can be, to the genetics, again, even with,
yeah.
identical twins.
Yeah, yeah. I think it must have been a different study then that I read that spoke to when it came to a lot of physical traits, you
Mhm.
know, genetics, that coding, that base DNA had a lot to say. And then when it came to more personality traits, save and except for certain mental health issues, that was a lot more influenced than by the environment. And so that wasn't a hard and fast rule, but
Mhm.
by and large, the physicality came out more through DNA. And then the environment influenced more when it came to personality, excluding certain mental health conditions. Yeah. All right. So why don't we dig a little bit deeper into this question then of epigenetics and, how that is set up within our DNA, how that curates, how that marks up the music, how our orchestra plays. And then we ultimately get to that question of what do we do about that? Like all that's fun and fancy, but how do we use that information, what we have influence over how our genes express, to change how we live our lives and to influence our health. Yeah.
Like a plan.
All right. So again, let's speak to it. So we know we're playing a piece of music, and we know what influences the music is going to be the instruments you have available and then how they're being conducted. Is that fair?
Oh, absolutely.
Yeah.
So, okay, again, let's set the stage, pun intended. So what we are looking at, again, using an orchestra analogy, I want you to imagine that your DNA as the sheet music for that grand orchestra. Each musician represents a different gene, and the notes on the sheet music are the instructions that the musicians need to play their parts. So the thing is, just having the sheet music doesn't guarantee a beautiful performance. I mean, I love my granddaughter, but put a violin in her hand and sheet music, you're not going to get very much. So,
Or
how
my hand for that matter.
how that sheet music or how that music is played depends on the conductor and various factors of the environment. So, DNA, that is our sheet music that
Mhm.
provides fixed instructions, okay? Tells each instrument, gene, what to do. Now, our epigenetics, that's our conductor. He controls which sections of the orchestra play loudly or softly, and even if some instruments are totally silent during a particular part of the piece, kind of quiets them right down. The conductor, they can signal certain musicians to play louder, turning a gene on, or to
Mhm.
remain quiet, turning them off. So, and he does that without changing the sheet music itself. Now, environmental factors, we're talking lifestyle choices, diet, stress. Okay, these act like the audience, the concert hall, or even the weather. These can influence how the conductor directs the orchestra. So, if you have an environment that is supportive, let's say, okay, you've got a well-tuned concert hall with ideal acoustics, the conductor might allow music to flow beautifully, it activates genes at the right time, everything is optimal. But you have a chaotic environment. Okay, so say you have really bad weather, it's storming, thunder, lightning, everything else. Bad weather can affect
Yeah.
unruly audience. Okay. Now we have a great audience here, but say there's an unruly audience. Well, the conductor might have to
Yeah.
suppress some parts of the orchestra, which can lead to a different performance altogether, even though that sheet music does not change. So really it is the conductor, epigenetics,
Mhm.
how he manages the music,
Yeah.
your genes, creating a very dynamic performance, your traits and your health. So even though your sheet music remains the same throughout the concert, it can actually sound very different with various things going on.
Yeah. And I think one thing I like about this too is the power between the conductor receives that information from the audience, from the weather, from those things that are very specific to that day. And maybe one night you're having a present, like a performance. And to your point, there's rain and thunder and it's loud and the audience is wet and they're not happy, right? And that music isn't going to come out great. But that does not mean that the very next day that can't change. Maybe it's sunny, maybe the environment, the audience is then much more happy, right? The orchestra is still going to have that memory, right? They're going to remember the performance before, they're going to be a little bit scared, but there's that power for them to change when those factors change and they can put on a better performance, right? So,
There's also the fact that the players themselves can be affected.
mhm,
Okay. They can be affected by the weather.
yeah.
They can be affected by, oh, lack of sleep. So they didn't sleep very well in the hotel that they were staying in. Yeah.
Don't call me out.
No, and we can dive in a
Yeah.
little more into that aspect, that
Yeah.
analogy into how the players are affected.
Yeah, so let's bring it back to epigenetics again, because I would imagine not everyone here is as in love with music as we might be. So let's bring it out and let's ground and let's talk about what are these variables that our conductor is actually trying to gauge against and instruct DNA against. Okay, so we have our genes, and we know quite clearly this is what we're told, that this is how our body, this is how our body is told to operate, how to sing. And so, what influences are going to impact what genes are expressed, not expressed, whether they're expressed in healthy ways or not healthy ways?
Okay, so, well, first of all, I do have to say that the genes themselves, in order for them to be expressed, they need to be present.
Yes. This is
So,
this is true. This is true. So,
and I will get to that part of your question, but we need to understand when we have an orchestra, well, you have to have all your instruments, right?
mhm,
Yeah, and they have to be tuned, and you have your players, and do they know what they're doing, and do they know how to read the music, and do they know how to play? And it's really important that in order to affect the genes, you got to know what you're working with. So it's the one of the things that I tell my clients, that in your genes, you're dealt a hand, and you just have to play with that hand.
yes.
So for the orchestra, you have certain groups, your violins, your violas, your cellos, your woodwinds, your brass, your percussions, you've got all of your players. But what if you have some null variants?
Yeah. Yeah.
If you're not playing with that full deck, if you are missing some, that is going to affect the ability to even express certain genes.
Yeah, so allow me, I'll offer myself up the sacrificial lamb to example here. So, for example, we in our DNA 360, we examine a suite of genes called the glutathione S transferase. Really, what this looks at is how do you take your glutathione, which is one of our strongest antioxidants within the body, and how do you actually attach it to an antioxidant? So we look at how good are you at attaching, and this is looked at through copy number variation. Okay. And so this is in an instance where some people, myself included, don't have copies of this gene. Okay. So what that means is it doesn't impact how I'm making my glutathione, but it does impact how I'm attaching it to things. I have two GST genes where I don't have any copies. I got nada. I am missing a whole brass section when it comes to my detox. Okay. So, what does this mean? It means, first and foremost, I don't have a brass section, right? There's nothing I can do to change that. My DNA is not there. Now, this is where the importance of a conductor, diet, and lifestyle comes in. Does that mean I can't detox? No. Some days it feels that way, but no, that doesn't mean I can't detox. It means that the conductor, as well as my diet and lifestyle factors, come in and say, okay, we don't have a brass section. We're going to compensate. Other detox systems that you do have, we're going to ask you to play a little bit louder. Okay, so there's this incredible interplay, as Dr. Varden is speaking to here, as to awareness of what sheet music do you actually have? Do you have all the instruments? I'm missing my brass section. And because I'm missing my brass section, it's really on a combination of the conductor, my epigenetics, to say, cool, we got to emphasize some other stuff, as well as it's on me to ensure I'm not taxing or expecting my brass section to all of a sudden show up. Because as much as I would love to magic in brass section, because it's my favorite part of the orchestra, it's not going to happen.
Oh, no, come on. What instrument did you play?
Oh, she's calling me. I used to play the viola, except I would play it as a violin because I love the sound, but I think the viola should be the violin when it comes to being spotlighted.
I played the violin, so you and I can play strings together.
There we go.
She always could have picked up like a tenor sax or something. So getting back though, it's like no matter how much we like or want something, we have what we have. So
Hmm.
embrace that. It's also good to know what you do have and what you don't have. And I'll tell you, the only way you're really going to know that is if you get your DNA done.
Yeah.
Seriously.
Yeah.
That as a foundation, know what instruments you have playing for you. So that way you know what you can lean in on, where you're weak, so that way you don't put yourself in situations to cause more damage or put more stress on your body. Because now we're getting into, okay, you were asking, well, what can we do? How do we help our body, help the conductor, help the orchestra play? Well, that really is a matter of that conductor, your epigenetics, managing those musicians that you do have. So once again, you need to know who you've got. Okay.
Yeah.
So that's first and foremost. But it is telling them when to play, when to be silenced. And
Hmm.
this is strictly influenced by environmental factors, lifestyle factors, both positive and negative.
Yeah.
Okay. I'm going agnostic here. It doesn't matter. Whatever you experience, and it doesn't have to just be the food that you eat or, toxins that you may be exposed to. We're also talking about our internal.
Yeah.
We are also talking about how do your genes, for example, your estrogen metabolites in your hormone section. Do you make more of a particular, one of the inflammatory metabolites that could cause more inflammation in your cardiovascular system? Okay.
Hmm.
So knowing that you can manipulate or change up some foods that you're taking to help.
Yeah.
Um, you know, but having that knowledge is really important.
So I'm curious, can we measure or take, is there a test that can tell us, or do we have science that can tell us from an epigenetic perspective what our, oh, the famous cat is here. Um, from an epigenetic perspective, what is turned on, what is turned off? Do we have testing measures that
Oh,
can tell us about our epigenetics?
yes, absolutely. And this is a burgeoning field, and it really gets into that epigenetic testing, DNA methylation. And, this is where our DNA gene test comes in. That really provides a snapshot, for, what has been going on in your body the last several months. Where are you at? And there are many different systems that are looked at. And actually, I would love to hear your input on, what is included in that, and or the kinds of things that
Mhm.
to look at, uh,
Yeah.
looking at
Yeah.
methylation and these epigenetic testing.
Yeah. So I'll start off by very pointedly saying science is not yet at a place where if I say I have the ApoE gene, is it turned on or off? We don't have that precision, that technology. Instead, what we do have, and this is really important, we have more pattern recognition. What does that mean? Okay. So let's pretend that you've been sick for a really long time. You're really taxing your immune system. You're very inflamed. Okay. That will create an epigenetic, a methylation pattern on top of your DNA. And I say pattern insofar as if I am undergoing that stress, and heaven forbid Dr. Varden is also undergoing that stress, ultimately we're going to have a similar pattern that expresses that inflammation and that immune burden on top of our DNA. Her and I have very different DNA, but this pattern on top of it will start to emerge. Just like separate to this, if you have someone who is eating too much sugar and on that tendency towards diabetes, or if you have someone who, isn't taking care of their cardiovascular health and they have high blood pressure and high lipids and high things like that, all of those will start to create a pattern of epigenetic methylation markers. So while I can't go in, or while we can't really go in and say, is this singular gene turned on or off? We can look at DNA, and first of all, we can call out what are patterns that we are seeing. Are we seeing stress when it comes? Is the DNA stressed by an ongoing pattern of inflammation or immune suppression? Is your DNA stressed because you're on that verge of getting, of getting close to insulin dysregulation? Are we seeing cardiovascular, right? And so these patterns can bubble up to a larger question, that larger question being, how old does your body think it is, right? This is really the question. If everyone has the same DNA, how old does your body think it is? How old does it think it's aging, right? Because these markers, this notation atop your music, atop your DNA, can give us insight into how old your body thinks it is. So there is testing, one of which we offer is really that rate of aging. So we're able to take all those methylation patterns, right, from immune, from cardiovascular wellness, et cetera, and we're able, through the magic and the power of computers, to say this is how you're aging. Your body either thinks it's aging quicker than a calendar year, or it's realizing that it's aging slower than that. And this is a really, really good gauge, right, as to those environmental factors that are burdening your body and then ultimately burdening your DNA. Right? Does that make sense? Did I answer and catch your question there, Dr. Varden?
Yes. Um, you know, we overlooked something.
What
We
did
want
we look?
to take a look at the poll question.
Mom, yeah, but of course. But of course. We got so excited. All right. Thank you, Dr. Varden. Would you like to review who our audience is here now that we're pretty much halfway through?
Absolutely. I know
You're
we get
important
wrapped
to
up.
us,
We're
we
so
promise, audience. You're so very important to us. Just clearly Dr. Varden's on the ball and I appreciate you.
well, our first question was, how familiar are you with the concept of epigenetics? And we've got a good share of you, 40% saying somewhat familiar. Then almost an even split between very familiar or actively using epigenetic principles in your health strategies. Good for you. I am so impressed by our audience. Very well informed. And, I am also so thankful and impressed for those of you who said, never heard of it. And I'm sure that is why you are here tonight, to learn some. And, this really is for you, to ingratiate you into this knowledge and to help you be one of those who are actively using epigenetic principles in your health. So thank you all for being here. Our second question asks, have you ever made a significant lifestyle change? So we're talking diet, exercise, stress management, anything like that, to improve your health based on personalized insights, things like using your genetics or specific health data. And we've got almost 50% saying, yep, based on genetic or medical testing. We've got almost 40% that said yes, based on general health advice. 11% of you said no, but you are interested in doing so. And 3% saying no, haven't made any changes yet. That's the optimal word, yet. And our third question, what percent of your health and well-being do you believe is influenced by your lifestyle choices, like diet, exercise, stress management? Of course, we've talked about this at the top, but we have, excuse me, 61% said that 76 to 100% of your health and well-being is influenced by lifestyle choices, where 29% said about 51 to 75%, and 10%
Yeah.
said 26 to 50%. So
I would offer there's some intelligence within our audience because I think, we talked about heritable traits, how you present, how your body, et cetera, how your behavior might be. And I think that sits, within that 50% range, which is what 30, 40% of our audience. The other 60, I think, really speaks to the idea of lifestyle disease. So, for example, the World Health Organization has said that cancer is 80%, in certain cases even more, so example colorectal, more than 80% attributable to diet and lifestyle, right? It's a very small percentage, and usually those tend to be pediatric cancers that are exclusively influenced by DNA, right? So
Mhm.
I think I would offer we have a very intelligent audience simply for the way they answered that question. I'm so grateful that 0% of people said 0 to 25.
Definitely. Our final question: what is your primary motivation for attending this webinar? And we had about almost 40% saying learning how to use epigenetics to
Yeah.
improve my health. And almost 20% saying explore ways to prevent aging and disease. We've got 10% saying gain personalized insights for my patients, clients. Love those practitioners being here, expanding their knowledge. Thank you for being here. And then we've got 33% saying discover new strategies to optimize my lifestyle choices. That is absolutely beautiful. And, you know, it's, I want to tell all of you that you already know a lot of this, the foundations, um, either that you've heard about it, that eating healthy, exercising, getting good sleep. These are your foundations. These are direct environmental lifestyle factors that directly impact the expression of your genes.
Yeah. 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 And I think let's kind of speak to that percentage, that large percentage of the audience that said, I want to know exactly how I can leverage epigenetics. And so I want to make a statement, and then Dr. Varden, let's explore, clinically speaking, from more of a practical testing perspective, how you can go about this. But I think, and we've said this at the top of the hour, you said this at the top of the hour, the first and most important thing you need to know about epigenetics is that you can change them, right?
Yes.
If you go in and you get our DNA aging test, for example, and it says you're aging pretty quick, right? Your body thinks a calendar, your body thinks that within that one calendar year, it's lived two, right? There is a power to change that. So first and foremost, before we dig into the practical, let's talk about what testing or how clinically you work with it. It's so important to know that you have the capacity to change your epigenetic coding, right? Just like the orchestra, if they have a bad night, that doesn't mean the next day is going to be bad, right? You can change that.
Absolutely.
Yeah.
So, and it's also a matter of, like I had mentioned, you already know a lot of the things,
Yeah.
but do you implement them?
Yeah.
How consistently do you implement them? Not to say that you can't periodically, you know, go out to dinner and have, some pastries, or have, a glass of wine or a beer, or doing this. And that's the nice thing, is that if you have consistency in these factors, in lifestyle choices, in diet, where you are keeping your orchestra tuned, practiced, that they are rested, that they play beautifully, then having a beer once in a while, doing something that falls outside of the optimal health lifestyle, etc., you are more resilient. You can bounce back much quicker, because we want to enjoy life too. Not saying that being very healthy is not enjoyable. Yes, it is. Because having the energy to do the things you want to do is definitely worthwhile. I mean, that's really what we want to be able to do. I want
Yeah.
to be able to get on the floor and play with my granddaughter and be able to get back up. You know?
You got to know your why, right? You got to know your why.
Yeah. So knowing your why
Yeah.
is really important.
Yeah.
But
S-
letting you know that there is that dynamic aspect to it.
Yeah. So let's talk about this then. Let's talk about how one can leverage what we currently know of epigenetics to sincerely bring it into their healthcare picture. And we really emphasized both the epigenetic, those modifiable, how the conductor conducts things, compared to the score, your actual DNA, because both are really, really important to how you go about using your epigenetics. Okay. So let's say you get DNA aging test, right? We have the ability to know how quickly you're aging. Okay. We have the ability, um, through other algorithms, to really say this is because of inflammation, immune, and whatnot, right? So if you get this information, okay, let's pretend you're aging a little bit quicker, and you work with a clinician and you realize it's because maybe your sugars aren't in check. You're eating too many carbohydrates for whatever reason. The what do you do with that information, that epigenetic information, really goes back to your DNA 360, your actual genes. Okay. And this is really, really important. Your genes, again, are the score, that art of the possible, what you can do. And your epigenetic test is really what's going on in that moment. And what do you really need to focus and work on? So, for example, if it is, right, your poor insulin regulation, you want to not only understand from your DNA 360 what genes influence your carb metabolism, your insulin regulation, but separate to that, what appetite genes feed into that, what craving, what mental health, what mood and behavior genes feed into that, because you want to approach the problem from many different aspects so that you can kind of calm down that epigenetic stress that's on your genes. Dr. Varden, I know you agree, but I wonder if you could offer more thought to that, if you can, in your clinical practice, how you go about that.
That is absolutely the foundation. Because again, you have to know what you're working with. You have to know what instruments you have to play.
Yeah.
But then you need to start getting curious. And now stepping more into the epigenetic aspect of environment, stressors, the food that you're eating. So getting to your point, let's stay along the line of, maybe insulin resistance, having maybe higher blood sugars, your A1C is maybe a little high. Well, then we need to look at what foods are you actually eating? Okay. How are you eating them as far as the timing in the day? What is your food window? Because there has been research that shows not changing the foods you're eating, but just shifting the time periods that you are eating them, affecting your circadian rhythm clocks that are in all of your cells, tissues in your body, can impact hormone regulation, leptin, ghrelin, insulin, cortisol, all of these different hormones. And that can impact the ability to manage blood sugar, to manage, insulin resistance or sensitivity. Also looking at your stress profile, okay, looking at the genes, because remember, stress does affect
Mhm.
blood sugar regulation, insulin production. What job do you have? What do you do? How are your relationships? Are you married? Are you not? What stresses do you have in your life, and how can you navigate them in such a way to lower that stress level?
Yeah.
Okay. So it's asking a lot of questions and really analyzing your life.
Yeah, I one of my mentors, and I think we're going to shift into questions after this, but one of my mentors, when I was learning how do I approach clinical care, how do I take information from a patient, how do I marry that up with labs, he said, you really need to think of yourself like a detective. You have to take the story from the person before you, and then you have to get lab work that is either going to reinforce that story or make you question the story. Okay. And I think epigenetic testing is a very unique way to question the story because by and large, it offers us insight into things that are a little bit more difficult to assess. For example, inflammation, very, very difficult to assess, right? I can ask Dr. Varden, like, hey, how are you feeling? What are your energy levels like? If you get cut, how quickly do you heal? There's general questions I can ask, and I can look at some blood work. I can look at her HSCRP and ESR. There's a few blood measures I can take, but it's still really not a direct measure of that, right? Epigenetics allows us a little bit more to peer in. And so it's not to say that the person before me is lying. It's just that I have a different piece of information and I can challenge it and I can say, hey, maybe I didn't ask the right questions. And now that I see this epigenetic marker that says your body's pretty stressed by inflammation, I ask better questions and I'm able to dig in deeper to truly get to that root cause. The more data, the more evidence we collect, epigenetics being a really important piece of evidence, that by and large is not something that other measures will capture, is very important to how we go about addressing that, either what is ailing you or how do we get you living happily forever and ever, right?
Or at least to the best of your ability each day.
It's every day, right? It's a day to every day. Yeah, yeah. I think now is the moment where we start transitioning into questions, unless Dr. Varden, is there any other thoughts you wanted to offer before we jump into the Q&A?
Not at this time, and I'm sure as we get going into the questions that will propagate some other thoughts and
Yeah,
comments.
yeah. All right. So Barbara is our first question of the evening, and I think we've indirectly answered this, but I think we'll circle back and we'll kind of answer it again because sometimes I find, at least for myself, hearing it a second or third time is really important. So Barbara's asking, she's very concerned about how to modify behavior to mitigate problems with her ApoE4 allele. So before I pass this question to Dr. Varden, first and foremost, for those who haven't heard of ApoE, ApoE4 is a gene we look at, and it can tell us two different things. How are you managing lipids and cholesterols within the body? A lot of people with this 4 presentation are going to have heightened or dyslipidemia, so struggling with managing their cholesterols, etc. And then very separately, this is tied with association, or this is tied to outcomes of Alzheimer's. Namely, if you have this presentation, there's a greater risk of developing Alzheimer's. So very important question. She has this gene, which is concerning. How can we know epigenetically if it's turned on or off, and what can she do to modify that? So Dr. Varden, the first question, can epigenetics right now, with the state of science that we have it, tell us if that gene's on or off or how it's being epigenetically modified?
Well, again, like you had mentioned earlier, we don't have the in-depth instrumentation or procedures to be able to say, oh yes, this one specifically is turned off. And honestly, some of these you don't want turned off. It's a matter of how they are expressed and what we can do to make sure that we don't have the negative effects that can be connotated with them, which, like you had said, that ApoE is normally associated with Alzheimer's. Yeah, there's, I don't remember the exact percentage for people with that particular presentation, that there's, I don't know, 78, please don't, quote me on this, but I know it's a higher percentage of possibility, that you may get it, but there's still that other percentage that have that particular allele and don't.
Yes.
And this is the power of epigenetics and your
Yes.
power to modify it, that you don't have to go down that road. So,
Mhm.
particularly behaviors that can mitigate problems when it comes to ApoE4. Honestly, in my research that I have read in working with clients, a healthy diet is one of the most effective ways to
Mhm.
reduce that ApoE related risk. And I will tell you that in the epigenetic DNA methylation testing, they actually look at aspects of this gene in the way of different markers that are associated with it. I mean, there's like a suite of markers and genes that are assessed for cardiovascular health, for brain health, for mitochondrial health, for mitotic health, all of these different aspects that we can see that picture of how it would work. So, having a diet, and I don't know your specific uh, genes to be able to say, but in general, the research has shown like a Mediterranean diet, a diet that emphasizes fruits, vegetables, healthy fats, lean proteins, things like that, have been shown to reduce cognitive decline, cardiovascular risk from the ApoE4 carriers, and I'll clarify that. Omega-3s, making sure that you have high omega-3s, your DHA, your EPA, avoiding saturated and trans fats, especially processed foods, anything like that, reducing sugar, processed foods, very, very important. So the diet is probably number one. Exercise is another. That regular physical exercise can improve that brain health, cardiovascular function, both of which are important for ApoE. For ApoE, well, ApoE, yes, but ApoE4 carriers in particular. Also cognitive stimulation, anything that works the brain. You want to keep those neurons firing. What fires together wires together. You want to upregulate your BDNF, that brain-derived neurotrophic factor, to grow new neurons. To expand that capacity. So, be a lifelong learner, always learn something new every day. And of course, getting to sleep. Sleep and stress management are always foundational, along with toxic exposure, which we state in virtually every single webinar because it is so darned important.
On purpose. Yeah, on purpose. Um, and so Barbara, if you're looking for support, because I think if I could very briefly summarize what Dr. Varden is offering you, is there's an element of personalization there, right? It's really looking at how do we fit, how do we make diet make sense to you in prevention of that? And so you can absolutely come and work with us if you want. Dr. Varden is spectacular in this space. We also have Dr. Adelia Sapp, who's done additional training in this space. So different practitioners that can really ground your DNA against how do we implement it in your life, because it's often the personalization, right? To Dr. Varden's point, we kind of give the same advice: sleep, exercise, eat well, but for every person that advice looks a little bit different based on their life. And that's where the power of finding a really good clinician who jives with you well, that's where that power sits.
Well, and their genetics.
Yeah, we, but of course. Yeah. All right. We have a question and a comment actually coming in from Sue. And so Sue's, I love this comment. I'm going to offer it. It's not really a question, but I'll allow it to lead into her question. So the comment is, when we don't nurture ourselves, nurture suffers. And our nature suffers, sorry. And I absolutely love that. I think that's very beautiful. So Sue is asking the question: do we think meditation and really a lot of self-talk, just use very specific, talking to yourself, cells, but I would also offer cells as in your biology and self as in the person that resides within, that we can change our DNA? So my answer to this is going to be a resounding yes. I think the science and the mechanism behind this, yeah, I know Dr. Varden agrees. I think the science and the mechanism behind this is still being understood, but one of the easier things that we can draw back to science, so we're not kind of sitting out in the clouds, and I think sitting in the clouds is very powerful sometimes, but a very easy example of this is with stress. So we know categorically that when you are stressed, there's a lot of hormones and neurotransmitters that shift within the body. And we know that when that milieu, that your cells of your body are sitting in that gunk, that stress, that very, something that science and our current abilities with science can very easily understand, when you sit within that gunk, right? Your physiology, your cellular expression, your epigenetics change. And so we also know separately that meditation and how we talk to ourselves, okay, that influences our biology and our epigenetics. So while I don't think there is an elegant paper or an elegant understanding of the how, we have lots of little clues within science that are very suggestive that yes is the answer, right? And I think it's very powerful when science is able to take something, a thought, a dream, a hope, and ground it in actually, there's some truth to that. Dr. Varden, I know you're so very passionate about this space. Do you have any thoughts for Sue here?
Oh, absolutely. I mean, you're right about there not being a lot of scientific research that actually is definitively showing.
Start
Um,
to finish, but the little pieces.
but I'll tell you, the anecdotal evidence, personal, even anecdotal evidence of that, because everything is frequencies. Our thoughts are frequencies. Where thoughts go, energy flows. And this actually goes even back to, Chinese medicine, Ayurvedic medicine, acupuncture, acupressure, energy medicine. It does work. That again, we may not totally understand how, but it does work. And there actually has been more research done on frequencies, vibration frequencies and light frequencies, and all of these different types of frequencies and how they influence the words influence genetic expression. So that is coming, and then it's just a matter of, connecting the two where it comes to actual thought, self-talk. But a lot of it does get into lowering the stress, positive feelings, that vitamin G, gratitude,
Mhm,
and how that plays into overall health and well-being.
mhm. I love that. I love that. Thank you for articulating that. Dirk is our next question. So, Dirk is a two-parter, and I'll kind of take the first question there because it dovetails a little bit into one of my favorite subjects, that being computers. So, Dirk is asking what goes into determining um, that a gene has a particular function, how hard it is to make those associations between that. Is it brute force? Is it observation? He's kind of really asking, how does science go about figuring all this out? The answer, if you ask any PhD, is blood, sweat, and tears. Dr. Varden.
Uh-huh. Yes.
Yeah.
A lot of
Uh,
late nights, no sleep.
yeah. So that's a really big question, Dirk, and to answer it, especially from like a how do we know what gene does what, the answer is several different ways. So absolutely observational study. Dr. Varden kind of started us off by saying, like, we collected data and medical records on more than 15,000 people and 15,000 pairs of twins or something to that effect. I forget the number. And so there's comparison, there's that observational data. There's a lot of our mouse friends are often offered up and used to. We have very well genotyped mice, and we're able to chemically knock out certain genes, and so we're able to understand when you turn something on and off. What does that look like, right? And that will also lend into, I think now, especially as technology and especially genotyping is, relatively speaking, even relative to 5 years ago, but especially 10 years ago, much cheaper. That means we have a lot more data to do more analytics. And this is where computers come in, because there is absolutely an element of brute force, right? Now, our computers are getting bigger and bigger, which means we get to play with bigger and bigger data pools, but also we're getting more data. More people are offering their DNA to science to us to study. Okay. And then separate to that, there's also something called GWAS, genomic-wide associative study. Did I get that right? Yes.
Genome-wise association studies. to
Thank you.
us.
I appreciate you. I use acronyms and then tend to forget what it actually stands for. So there's a lot of GWAS studies. And so this kind of asks the question, I think this is a very interesting fun that computers are lending to, right? Computers are lending to this part of science. Instead of saying, the BRCA gene, the ApoE gene, et cetera, what exactly does this singular gene do? These are really able to say, if we have someone with breast cancer, and we have a lot of people with breast cancer, what SNPs, what genes, what parts of the genome are involved that aren't necessarily just an individual gene? What are certain combinations, right? And again, this is where computers come in, this ability to look at it all together. So we know all of this observation from mice, and then separately from computers and data that affords us, this big data research. Okay, so it's all of the above. Is DNA part of this research? Yes, we are. Joyfully and happily. Are we everything? Absolutely not, right? We're part of it though. We are amongst those championing and trying to understand this better to the end of offering it to everyone. Okay, Dirk's next question here, and maybe Dr. Varden, because I think we've indirectly spoken. You spoke to this when we spoke to ApoE, but I wonder if you can speak to this again. You said that we can't tell whether a gene is turned on or off, and that's true from that epigenetic perspective. And so he's bringing up Angelina Jolie, and so she very publicly, and someone might need to hold me honest here, she very publicly, I think, was genotyped, and based on family history and based on her own genotyping, was at risk for breast cancer based on her BRCA. And so she decided to undergo a double mastectomy, effectively removing the breast tissue, and therefore, and possibly even hysterectomy. I'm not familiar with it all, but she underwent several surgeries to mitigate her risk. And so the question is, why, if we don't even know if those genes are turned on or off? And so I think Dr. Varden will allow you to jump into the constellation that is the answer there. Yeah.
Well, I mean, as far as her story, and I don't remember all of it in detail, but I believe that she carried a mutation in the BRCA gene. And that gene mutation significantly increased her risk of developing breast cancer, ovarian cancer. So she ended up having, I believe, a double mastectomy to prevent any possible cancer. So, I mean, this is a personal thing. Did she have to do it? No. She chose to do it because with all of the information, there was family history of cancer. Her mother had died. Actually, I think it was around the age where I am right now, from ovarian cancer. She's had other members of her family also affected by cancer. There was just so much that she made the best decision for her at that time. I kind of wish that, maybe she had, met with us, and we could have shown her ways that she didn't have to make that decision, by making other changes. But then again, this is quarterback, Sunday, Monday morning quarterback type thing. That before someone makes that kind of a decision, to make sure they are fully informed of all of the choices. But just realizing, just because you have a particular genotype, a variant of a gene, does not necessarily mean you are destined to get that disease.
Yeah.
That's the whole point of informing yourself of your DNA, of, taking a look and working with someone who knows how to navigate those waters and empower that person based on their genetics, based on them, their history, everything about them, to really personalize, going, okay, here's the path you take. This is going to be a path where you can most likely not have that disease. So,
Yeah. And I think that's a very we make best decision based on what we know. And I think the very difficult part with science and being a clinical practitioner right now is that science is developing at a rate that we can't necessarily keep up with. So I would imagine when she made that decision, it was best at that time based on what people knew, as well as her own personal goals as to how she wants to navigate her health. And no doctor can ever say, this is how your health picture, your health decision should be. Our role, and we really encourage, when you're working with a healthcare provider, our role is to tell you what we know, to tell you the options, and to support an informed decision. It's not our job to say that's the right or wrong decision. It's our job to say, do you understand your options? Do you get that? And cool, we're going to help you make your decision and support that decision.
I mean, because ultimately, you, our audience, each one of you, you're driving the bus. It's your bus. You're driving. All we're doing is helping you navigate, kind of telling you, oh, here's a sightseeing thing down that road. Here's that. If you go down here, that's, most likely what you're going to find. We're just being your tour guides. We're providing information and history
Yeah.
and information to you, but
Yeah.
you're the one who ultimately drives your own bus and is responsible for your own life.
Yeah.
So,
Yeah. All right. We have a few anonymous questions here. So, to the anonymous attendees, how can diet influence gene expression through epigenetic mechanisms? I would say directly and indirectly. So, from a very direct perspective, right? Dr. Varden at the top of the hour spoke to the different ways, different types of epigenetic modification that can happen. So, for example, one of the things she talked about was methylation, right? And we know that involved in methylation, there's a lot of B as in Bob, vitamins, as well as some minerals like zinc and magnesium and a bunch of other things. And so you can very directly through your diet, if you deprive yourself of that nutrition, you deprive yourself of that mechanism. Therefore, you're kind of cutting yourself off from any ability to directly epigenetically express. Okay. Separate and apart from that, one of the first and most famous, I think, studies that really spoke to epigenetics came out of Ireland following the potato famine, right? They're able to look at generational data. And so the potato famine was looking at a period of time where a large portion of Ireland's, for many socio-political reasons, a large portion of Ireland's population did not have food. There was a state of starvation for several years, which is a physical stress as well as a mental stress. And there was modification within the genome that carried through several generations. And so again, that diet change, that trauma, if you will, is encoded, right? So that memory, that story, is encoded within the gene. So there's several different ways, both in the very much can you do the methylation portion to more how the body remembers that period of strife and how the body communicates that to future generations can also be influenced by diet. Yeah, Dr. Varden, I would imagine you're so wise in this space. Do you have another thought, another mechanism there?
well, I would say that we need nutrients because, like Dr. Kostroman had said, your B vitamins, these are cofactors for many pathways in the body. The amino acids, the glutathione, getting into detoxification pathways, all of these things, there are several molecules, nutrients that play a role in making these pathways happen. You're not going to be having methylation very well if you don't have your B vitamins. Where do we get our B vitamins? From our food. Our food is information. When we eat and break down, mechanically, chemically, and then our gut, breaking that down, and then we absorb it, then it gets into our cells and it acts as cofactors to make these pathways happen to then make the genes express. So they all have many different jobs, but yes, absolutely. What she said at the top of that question is it does directly affect as well as indirectly playing a role. So we have another question, which is wonderful, about how physical activity plays in
Mhm.
epigenetic changes. And this is such a wonderful question because we're thinking, oh gosh, how really does it work? And honestly, when you really start thinking about it and diving into these questions with epigenetics. So getting back to some of the things that I was talking about in the very beginning on ways that a DNA is affected, epigenetics, DNA methylation, histone modification, messenger RNA, these non-coding RNAs. So for example, let's take DNA methylation, okay? This is one of the most well-studied mechanisms of epigenetic regulation, all right? And how exercise affects it. Let's look at exercise. What do we think of? We think of muscles. So think of muscle-specific genes. Physical activity can actually reduce the methylation of genes involved in muscle repair, growth, metabolism, and therefore it allows these genes to be more easily expressed. It supports that muscle adaptation to exercise and improving strength. When we're talking about metabolic genes, so exercise can actually alter the methylation of genes that regulate glucose metabolism and fat storage. Studies have actually found that after a session of exercise, genes related to energy production and mitochondrial function can become demethylated, meaning that they get expressed again. Remember that DNA methylation silences a gene. Demethylation allows them to be expressed. And this is really important for enhancing insulin sensitivity and reducing that risk of like type 2 diabetes. Also, inflammation and immune function, all right? Exercise may reduce the methylation of the anti-inflammatory genes, and this allows for that greater expression of anti-inflammatory molecules. So at the same time, it can actually increase the methylation of pro-inflammatory genes, reducing their activity. So it has this push-pull, for anti-inflammatory, inflammatory, all of this helps to really manage that chronic inflammation, which is linked to many diseases like heart disease and cancer. And the list goes on.
Yeah.
So
Yeah. I think I remember one of the more accessible ways to kind of think about this is use it or lose it, right? And this applies to exercise. And one of the more easy examples of this is with the liver and with alcohol. So within our liver, we've evolved long enough with alcohol that there's very specific enzymes in the liver that help us break down and deal with what the body considers a poison of alcohol, right? And there are a group, all of us have these genes. There's very few deletions when it comes to this. Different strengths of genes, but everyone has genes that can deal with alcohol. Now, if you are someone who does not drink, right, the body's like, cool, I actually don't need to express any of these enzymes or any of these liver enzymes that deal with alcohol. And so there's an element of methylation and other things that will go in and just turn it down, right? But once you start drinking again, right, then your body's like, at first it's going to be a smack in the face because you don't have those enzymes, but then eventually the body learns and they're like, cool, guess I gotta start making these enzymes again. And it starts doing that, right? So this is kind of, it plays into exercise as well. The more you exercise, to Dr. Varden's point, the more you're going to be upregulating some of those positive changes. The less you exercise, the body's like, cool, guess we don't got to do that. And you lose that marking, that pattern that tells you to accommodate, support, and offer the benefit that exercise gives. Yeah.
So this anonymous attendee, boy, they've got a lot of great questions here.
They do.
So hitting on another aspect. So we talked about how nutrition, affects epigenetics. We talked about how exercise affects epigenetics. Now they're asking about lifestyle, environmental factors, things like that. Well, they had mentioned about lifestyle factors. So let's touch on that. So we covered nutrition, we covered exercise. Let's talk about stress management.
Mhm.
Yeah, chronic stress. That's been shown to cause negative epigenetic changes, particularly through the overproduction of cortisol.
Mm.
That's your stress hormone. That affects gene expression related to inflammation, immune function, brain health. When you're talking about having, this upregulation of these particular hormones that now, granted, we need cortisol, okay, but we don't want it chronically high. All right. So it's a matter of going, okay, lifestyle factors that can affect that. Well, if you are in a very stressful life, work, whatever, and chronically cortisol levels are high, then to counteract that, doing things like meditation, yoga, mindfulness, reducing the stress, or like Sue was mentioning about, the self-talk, talking to your cells, doing things to calm the nervous system, to lower the cortisol, that shows and affects, it actually reverses that negative epigenetic effects. And like deep breathing, oxygenation, just activating the vagal tone, helps to promote that parasympathetic nervous system. It helps to release these anti-inflammatory markers, and proteins from our genes, and releases that. And that's all epigenetic factors. So
Yeah. I love that. I love that. I think epigenetics to an extent is a story not only of your ancestors, right? We talked about that potato famine and how we can tell in genes. It's also a story of how you've been treating yourself and what you've been doing from your health. And so I'd really offer, right, if you get one of our tests, again, it's like, you're aging really quickly, or maybe there's too much inflammation going on and that's starting to impact your genes. Can you change that? Absolutely. Yes, 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 yes. This said, it takes a while for those changes to enact, right? You don't just change one day and the test is going to be different. There's quite literally biochemical activity that has to go about changing it. How do you get that biochemical activity to go about changing it? You have to change your habits and your health practices. So to Dr. Varden's point, if you're starting to see that stress marking upon your DNA, you have to change some of your stress management habits. If you're starting to see that hypertension, that cardiovascular picture showing on your DNA, you have to change that. And that's not overnight, right? Those are things that you work not only with your practitioner to do, but separately you look at your DNA 360, understand what sort of orchestra do you have? Are you missing your brass section? And if so, what do you do about that? How do you go about supporting the orchestra? Yeah, love that. Ah.
and I think our anonymous is rounding off the the aspect of environmental factors, because one thing we didn't touch on is toxins. How do toxins and pollutants affect our epigenetics, the expression?
Mm.
Yeah, well,
Mm.
let me do a little bit more of a broad brushstroke on this, because I know we've got a couple more questions, and we are coming to a close of our webinar. But exposure to harmful substances, so we are talking heavy metals, pesticides, tobacco smoke, mold, things like that, it can actually cause apparent DNA methylation. That means it's outside of the normal. So we're talking about, it can cause either hypermethylation. Okay, so it's hypermethylating, say, tumor suppressor genes. Tumor suppressor genes suppress, okay, slow down tumors. Okay, actually, the BRCA gene, it is a tumor suppressor gene. When you have a variant, it is not doing its job as well to suppress the proliferation, uncontrolled proliferation, splitting of these cells. Okay, so therefore, if we are like silencing tumor suppressor genes, it's going to increase your cancer risk. Or say you are hypomethylating oncogenes. So they're not methylated. That means that they are able to express more easily. Oncogenes are genes that upregulate or activate their cancer promoting genes. Well, we don't want those to be expressing a lot, okay? But toxins can change the methylation patterns and actually can increase cancer risk. So that's one major issue that a lot of people are worried about. It is one of the top 3 killers, you know.
Yeah.
So
Yeah. It being direct assault, i.e., it directly damages your DNA and the way the cells replicate, or to Dr. Lara's point, it shifts some of those control mechanisms that we have, in the sense of, if a cell starts to detect cancer, we can shut it down. But if there's the pollutants there that have damaged that, you no longer have those controls and you increase your risk. Yeah. Yeah. No. Beautiful, beautiful articulation there, and a very wise call out, because there's certain environmental elements to an extent we don't have control over. Yeah. Yeah. All right. I There's one other question here in regards to, and I think we spoke to this, but we'll still offer an answer yet again. How does a DNA co-practitioner, someone within our clinic here, use the extra reports that come alongside this epigenetic test? They want to, how do they use them in practice? So again, very much like a detective, right? We're going to hear the story. We're going to hear what your health goals are, as where you want to take your health. And then we use this as one of our means and mechanisms to not only validate what you're saying, not to the end of your lying, but we collect extra data. It will tell us, like, hey, is your body aging faster? If you come in and you tell me I am in a great state of health, but then we see this epigenetic marker that's saying you're aging pretty quickly, it's not that you're lying. It's just that something isn't adding up and we have to investigate more. And based on that investigation, we then know how to better support you, right? We now know, maybe you think everything's going great, but you're not eating a diet that's supportive. Maybe you think everything's going great, but you're not getting enough sleep or enough estrogen support. All these things that kind of your genes, your DNA 360 might tell us might be off. So it's a different way of looking at you. It's a way, especially for certain inflammation markers, right? It's really helpful to know, because inflammation is really hard to quantify as a clinician. Yeah, so that's how it can be used. Let's see here. Dirk is asking a question. Okay, so this kind of gets back to, I would imagine, I confessed I don't have some detox genes. I'm the canary in the coal mine. Is it possible to not have any alternate pathways for detox? Would then one have to live in a bubble? So there are instances of very frank genetic mutations that have people living in immune compromised quarters, right? So very sanitized environment. I would offer, though, there's incredible resilience and redundancy within our coding, right? So within our tests, we look at methylation, we look at glucuronidation, we look at glutathionization, we look at antioxidant pathways. There's many different ways that we approach. And even if you're suboptimal per se in some of these pathways, most pathways outside of glutathione and to a small extent glucuronidation, you're still going to have those genes, right? Not everything is copy number variant as it is with glutathione. So short of, there's a few very specific that are more genetic mutations as opposed to genetic presentations, right? There's always going to be that redundancy and that resiliency within genes. You just need your DNA 360 will help you understand where you're strong and weak, and then you play to those strengths and support those weaknesses.
yeah, and I do want to say that it is extremely rare that anyone would be lacking all of their detox pathways. Honestly, it being a genetic thing, they probably wouldn't survive much longer after birth, if they even if there is a live birth. You know, it that is what it is. So if you've survived this long and you're just having issues, no, you've got detox pathways that are working. It's just a matter of taking a look and leaning in on the ones that are there and working well, and Renavigating. Again, you're driving the bus, we're giving you the map and guiding you so that way you can rebuild yourself. So,
Yeah. All right. And our last question of the evening has to do with methylation. All right. So, um, someone who's offered their initials. So this person is asking, they've they learned through a test that is not ours that their methylation genes might be suboptimal, and there was a big focus on MTHFR. This is the notorious, get ready for it, motherfucker gene. Excuse my language, but that is what it is often called, and that is what I will call it here. And so that gene, so here's what I would offer, right? There's a lot of tests that go in and focus on one gene, right? Today we've been using this analogy of an orchestra, and we're doing that on purpose, right? If you are given a sheet of music, you don't look at just one instrument, one player, you look at the collection. Methylation is no exception to that rule. Okay. Methylation has many different genes, many different enzymes, and it's really important to analyze all of that. And here's why. So the MTHFR, that motherfucker gene, some people who see that they have a suboptimal presentation here, they're like, cool, I got a supplement with methylfolate, and I start taking it. And a few weeks later, they come back and they're like, I don't feel good. One of the reasons for that can be attributable to two different genes, SHMT1 or COMT. Okay. And so if you don't know your presentation's there, taking methylfolate might be a bad life decision for you. Okay. So it's not looking at one gene that a lot of some of these robots on the internet will do for you. You have to look at the suite. And so I'd really encourage, before you start dosing yourself with certain B vitamins or hyperdosing with certain foods, right? You mentioned liver in here. For those that consume animal product, it has incredible access to B vitamins, incredible access to minerals, all of which go into methylation. That said, you want to know your true need based on your genes. You also want to know your true need based on your blood work. You may not need additional B12. Your current diet, whatever that might be perfect as is, right? So there's a few different things that go into answering that question. I think it's really important. Okay. Yeah. All right. Dr. Varden,
yes.
does all this feel good? Do you think you scratched all the nerdy itches that you had, as well as all the clinical pearls that you wanted to offer our audience?
I definitely think that we have touched upon some incredible information, and I hope that the audience thinks so, because ultimately it's not for me. This is for you. Did you get, information out of here, especially for those people who didn't know anything and who were interested in finding out more? Um,
Mhm.
it's I personally think that we did uh, touch on and really work our main takeaways. How epigenetics works. What is it? What does it do? How is it affected? Not just that, but that it is modifiable. I hope you all have that bottom line takeaway, that you have the power through information, that you're getting here tonight, through your research, through, finding out more and your questions, that you are understanding that more and more and empowering yourself to take control over your life, to make those modifications in the most optimal way, because we want to have you have the most beautiful sounding orchestra, that symphony to play your favorite piece of music. Which, by the way, Dr. Krista, what is your favorite piece of classical music?
Oh, okay. So I go through phases when it comes to classical, and right now I've been doing a lot of French opera, so I'm going to say Debussy, but ask me in a month and my answer will be different.
Well, I got to tell you, I'm glad you said Debussy, because Claire de Lune has been one of my
Mm,
top favorites um, for decades. So,
mm, rightly so.
and I want to ask each one of you, think about your favorite music. Go turn it on. Listen
Mm.
to that music. Let it infuse your body, your soul. Music and dance and move. Feel those frequencies. Allow that parasympathetic nervous system to be activated. Get into that calming state. Get into that healing state. Find and let it touch your soul. So, with that, thank you, everyone. Thank you for being here. We hope you're walking away with more information. And Dr. Krista, you are so amazing. I love working with you, and
Likewise.
I appreciate all of your brilliance. And I can't wait to do this again tomorrow.
Yeah, yeah. For those that have hung on to the end, you're getting a Dr. Varden, Dr. Kosterman duo all week. So join us tomorrow. I think we're talking about BDNF. Hold me honest.
Yes, we are.
There we are. All right. So we're going to dance out. We'll dance into tomorrow. Until then, thank you everyone so very much. Dr. Varden, as always, thank you so very much for offering us your brilliance and your explanation in a very human way. We appreciate your human. Au revoir, mes amis. Au revoir.